When we began brainstorming ideas for our project, we decided that we would like to continue our work with people who are affected by blindness and low vision. We enjoyed learning about blindness and working with Father Rick, the priest who says Mass at our school, who lost his vision in surgical complications. We realized that there is still very little on the market to aid people who are blind in transportation and navigating their community independently. GPSs exist that are specifically designed for people who are blind, but in many designs the system is stored in a heavy backpack that the user is required to tote around. Furthermore, they do not work off-road in a similar setting, and they have a chance of losing signal, which could be potentially hazardous.
We went to the Sight Center of Northwestern Ohio where we met Kevin, a technology specialist who is himself blind.
He gave us lots of ideas for technologies that could be helpful. One of our favorites was a technology that would aid someone who was blind in utilizing the public transit system.
We had not really considered how much of an impact transportation has on a person's ability to have a job. We thought that this was an aspect we could focus on.
Someone may be completely qualified for a job, but if they cannot find a reliable mode of transportation, they may be unable to be prompt in arriving to work, which may not enable them to keep their job. Kevin, who is himself experienced in utilizing the public transportation system, told us that he is capable of navigating to the street on which the bus stop is located, but he has difficulties finding the exact location of the stop. He says that it is difficult for him to determine if the stop is 10 feet ahead, 20 feet, or even if he has already passed it. We thought that this was a very interesting problem that we would be able to find a solution for.
You need to locate a bus stop. Sometimes bus stops may not be directly on a particular corner, or they can be at different locations and different sides of the street.
Simply stated, our objective was to design a product that could inform people of where a bus stop was while also alerting them if they pass it. We figured that in order to be effective, the design would need to play off of auditory cues rather than visual. This reasoning pointed us back to our design from last year. This project was a device that had been designed for Father Rick to assist him in navigating through the school. However, being used for a different application and being a new design, significant changes were made to the design that we now call the pathway.
In many cases, engineering is the revision of old designs and the application of new technologies to make it better. Through this method, many changes were applied to make the pathway what it is. Because it is to be used outdoors and we wanted installation to be as simple as possible, we did not want for the pathway to draw its power from the electrical grid. We decided that solar power was the best power source for the design, so that the batteries would never need to be changed and little to no maintenance would be required after installation. The solar cells replenish the 12-volt battery, and because the buzzer draws only 350 milliamps, the setup poses little risk of running out of power in the event of a string of days with little to no sunlight.
Another pivotal change is the buzzer's design. In last year's design, the buzzer sounded very similar to an alarm, which at first startled many of the students. They grew accustomed to it in time, but because the new design would be placed outside where many people can hear it, we realized that the buzzer could not have an offensive or startling sound. We decided that it would be effective and informative if we utilized a buzzer on which we could record a voice that states what bus stop it marks. We were originally worried that the auditory signal would not be an easy one to follow because our testing had shown that high-pitched sounds are more difficult to clue in on and follow than those of a lower pitch. However, when we spoke with our testers who are blind, they informed us that the different sounds should not have an effect on their ability to determine its location. Okay, and you found it?
Yep.
On the back or somewhere here.
The first step in construction was to make the breadboard that would produce the basic sound. This is connected to a relay of the board that we purchased to receive the signal from the key fob. From the breadboard, the signal is sent to the buzzer that produces the sound of a recorded voice. The device is powered by a solar panel that replenishes a 12-volt battery. The design is 100% green and completely self-contained. It is currently housed in a cube with dimensions of 7 by 7 inches. The design could be downsized further by using microprocessors and nanotechnology. We have found parts that with more experience we could install and construct the pathway at a size of less than a 3-inch square.
Our vision of the future of the pathway is that it will be utilized not only in our town of Toledo, but in communities all over the country. It is very difficult for people who are blind to join the workforce when they cannot find a usable mode of transportation. We would plan to market our design to the bus systems and at a total cost per buzzer system of less than $50, it is at a competitive price. The owner of the system could then sell the key fobs that produce the signal to the consumers for a profit. Furthermore, we envision a system that could lead someone not only to the bus stop, but that could be purchased by business owners and placed above their establishment, so that the users could press a different button and hear a buzzer call out, Bob's Diner, restrooms, pharmacy, or Dr. Smith's general practitioner, so that an audible map could be set up in the user's mind, allowing him or her to not only commute independently, but to stop and get a coffee or fulfill any other needs they may have.